Hello everybody, how you doing? This is Mr. Dowse, and in today's lesson I'm going to discuss different types of problems you might come across when dealing with slope-intercept form problems. And so these are the kinds of problems I give my students on their homework, the quizzes, and tests. And so it's likewise, or probably going to be similar for your teacher and the kind of problem she gives you. And so I've got 4 examples. Let's just jump in the first one. It says write an equation of a line in slope-intercept form with a given slope and containing the given point. And so it says, again, let's read it. It says write an equation in slope-intercept form. So in slope-intercept form, and I wrote that down here already for you. We have y equals mx plus b. So our goal in this problem is to come up with a slope, which is the m, and come up with the y-intercept. And then when I get numbers in for both the slope and the y-intercept, then you'll be done with the problem. And they gave us some information to help us figure that out. And so it says with a given slope and containing the given point. And so they're actually being nice here. They're actually giving you the slope. So on this problem, y equals, we know what the slope is. It's a negative 5 over 4. Now keep in mind here, x always goes after slope. And then we do not have the y-intercept. So we're missing this b here. If I can figure out what the b is, or the y-intercept is, then I'll be done with the problem. So it's write an equation of a line in slope-intercept form with a given slope and containing the given point. And so we know that the line is crossing at this location. It says it's containing the given point. And so let me plot this to help explain it. It goes 1, 2, 3, 4, 5, 6, 7, 8, down 1. And so we know we have a line here that at some point is crossing this location at 8, negative 1. And so we can use that bit of information to figure out where the line's crossing the y-axis, and that's what the y-intercept is. And so we need to use the slope here. If I were to plot the slope of negative 5 over 4, the line should cross the y-axis at some point here. So let's plot negative 5 over 4. Down 1, 2, 3, 4, 5 over 1, 2, 3, 4. It's right around here. Is that getting me closer to the y-axis? It's actually leading me away. And so I need to actually go the opposite direction here. And you can kind of see here, the line should be going up in this direction over here. So I'm going to actually go the opposite direction. Instead of going down 5, I'm going to go up 1, 2, 3, 4, 5, back 1, 2, 3, 4. And you can see here we're getting closer to the y-axis, but I'm not quite there yet. Up 1, 2, 3, 4, 5, back 1, 2, 3, 4. And you see right now we are actually at the y-axis. So if I were to connect these dots here, I'm going to cheat and I'm going to use a little tool that I have on my computer. You can see that this line is crossing at this location. And so this is at 1, 2, 3, 4, 5, 6, 7, 8, 9. The y-intercept here is 9 in this case. And so we actually know what the b is here, or what the y-intercept is. It is a 9. And so if our goal was to write an equation of a line in slope-intercept form, I've done it. I'm done. Equations in slope-intercept form, we only need the slope and the y-intercept. We don't need to put anything in for the y and the x. And so we're essentially done here. But I want to throw you a curveball here. What if your teacher didn't give you a graph? Or what if the test didn't give you a graph? Is there an alternative way of solving this problem? And the answer is yes. I'm going to move this down a little bit because I'm going to need the extra space. So I'm going to show you how to solve this problem without using a graph. And so I'm going to start back at this equation that we had here earlier. I'm going to plug in the slope here, but I'm going to leave off the b. I don't know what the b is. I can actually use these numbers here. They give me an x coordinate and a y coordinate. I can plug in the x for this x here, a y under this y, and we can figure out what b is here. And so let's do that here. We know the y is a negative 1. Let's just go back to red here. I have a negative 1 equals, we have a negative 5 over 4. Now the x is 8. And then we have this plus b. And so we have one unknown, we have one equation. If we have one unknown and one equation, we can mathematically get the b by itself here, and we can figure out what the y-intercept is. And keep in mind, it should be this 9. And so whenever I have a fraction times a whole number, you can plug this in your calculator, and it'll get it to you. But I'm just going to put a 1 underneath this 8. And whenever we multiply fractions, we just multiply going straight across. So a negative 5 times 8 is actually a negative 40. And then a 4 times 1 is a 4. And so I'm going to keep going here. I'm going to move this down a little bit more. I have a negative 1 equals negative 40 over 4 plus b. You can simplify this in your calculator, or you can just do it in your head. 4 goes into 40 10 times. So we're going to have a negative 10 plus b. And I need to isolate this the b by canceling out the negative 10. To do that, I need to add 10 to both sides. And I end up having 10 minus 1, or 1, negative 1 plus 10 is 9, and 9 equals the y-intercept of b. So I kind of squeeze this in. But when all is said and done here, we end up getting the equation y equals a negative 5 over 4x plus 9. And that matches exactly what I have up here. Now remember, whenever we're doing slope-intercept form, we're not plugging in numbers for the y and x. Those need to stay a y and an x. We're only plugging in values for the slope and the y-intercept. So anyways, hopefully this helps you understand a little bit better how to solve this kind of problem with and without a graph. Let's move on to some problems that are going to be a little bit quicker. It says right here, write an equation of a line in slope-intercept form containing the given points. And so unlike the last problem here, we don't know what the slope is, and we don't know what the y-intercept is. We're not given either one of these bits of information. But we know that the line contains these given points, meaning that the line's crossing both of these locations. And so I have a graph here, and so I'm going to jump over here. I'm going to plot these points on the graph. I have a negative 3, back 3, up 3. That's this guy right here. And then I have a 6 over 1, 2, 3, 4, 5, 6, up 1, 2, 3, 4, 5, 6, 7, 8, 9. And so we have right here 2 locations. And we could, well, I'm going to figure out what the slope is here using rise over run. So I'm going to do the slope here using rise over run. And the rise is up 1, 2, 3, 4, 5, 6. The rise is a positive 6 over 1, 2, 3, 4, 5, 6, 7, 8, 9. So the rise over run is 6 over 9. And I can simplify this down to 2 over 3. And so we know the slope. In other words, if I go up 2 over 3, up 2 over 3, up 2 over 3, I get right back to this given the starting point here. And so, or sorry, the second location. And so if I were to connect these dots here, we would have a line. And so that actually gets us the y-intercept. If we look here, the y-intercept is where the line is crossing the y-axis. It's crossing right here, and that's 1, 2, 3, 4, 5. And so b is 5 in this case. And so when all is said and done, we have y equals, the slope is 2 over 3x plus 5, and that is our answer. Again, if we did not have a graph, we could have plugged these 2 points into the equation m equals y2 minus y1 over x2 minus x1. We could have still found the slope that way. I have a video on how to do this if you want to watch it. It's the slope equation. And then we also could have done what I did in the previous page, which was once we find the slope, we can just plug it into plug one of those coordinates into this point. In fact, let me just do that here. Let's say we found the slope using this equation here, and we had the slope was 2 over 3. Let's solve this here. So we would have y equals 2 over 3x plus b. You can actually pick either one of these coordinates to plug into this equation here. You can do the negative 3, 3 or the 6, 9, and it's still going to get you the 5. I'm going to choose this one here because it has 2 positive numbers. I have a, let's see here, let me change this color here. So we have the x is going to be the 6, the y is going to be the 9. And so if I were to do this, we would have 9 equals 2 over 3x. Oops. 9 equals 2 over 3 times 6 plus b. This is a b. This is the letter b, the y-intercept. Sorry, my b's and my 6's look similar to each other. And so if I were to keep solving this here, I'm going to put a 1 underneath it. 2 times 6 is 12. 3 times 1 is 3. 9 equals 12 over 3 plus b. 12 divided by 3 is 4. So we have 9 equals 4 plus b. If I subtract 4 from both sides, you get 5 equals b. And that's how we get this 5 up here. Again, I could have plugged in this negative 3, 3 in here as well. We would have still gotten the answer 5. And so again, if you didn't have a graph, you can always use this equation here, m equals y2 minus y1 over x2 minus x1, and then you can solve for b using one of those coordinates. Let's jump on to the third example here. It says, write an equation of a line in slope-intercept form with a given slope and y-intercept. And so they gave me the slope here, so we have y equals 5x, and then they're telling me this is the y-intercept. So is this going to be a plus 0, or is this going to end up being a plus 2? Let's figure out. Let's plot this point here. 0, 2 is right here. And let's see here. If I were to plot the slope of 5 over 1, 5 is just 5 over 1 as a fraction. I can go up 1, 2, 3, 4, 5 over 1. And I can go back 1, 2, 3, 4, 5 over 1. And you're going to see here that we have a line that's actually crossing at this 2. And so on this problem here, this number is actually going to be b. And so this is actually going to be y equals 5x plus 2 here. And this is our answer. So whenever we have a 0 for the x, that means that we have to be on the y-axis, because I'm not going anywhere in the left or the right direction here. And so anyways, so this is pretty quick and easy. If we had the same problem here, let's say, and this was a 0, negative 4, then your answer would have been y equals 5x minus 4. So whenever you have a 0 here, they're actually giving you the y-intercept. The last problem we have here says write an equation of a line in slope-intercept form that satisfies the given conditions. And so right here they say the x-intercept is 6, the y-intercept is a negative 4. So we actually know y equals, we don't know the slope, but we know the y-intercept here is a negative 4. And our goal here is to find the slope. Well, a y-intercept is a negative 4, so that's going to be down 1, 2, 3, 4. That's the y-intercept. The x-intercept is where the line crosses on the x-axis. And so it's actually 1, 2, 3, 4, 5, 6. And so this is the x-axis here. And so if we connect the dots, we have a line, and this is where they're crossing the x and the y-axis. And so since we have 2 points, we can do rise over run here to find the slope. And so let me erase that right here. So we can do rise over run to find the slope. The rise is going to be up 1, 2, 3, 4. So let me write this down. Slope is rise over run. The rise is up 4, and the run is over 1, 2, 3, 4, 5, 6. And I can simplify that down to 2 over 3. So this equation actually becomes y equals 2 over 3x minus 4, and that is our answer. Anyways, sorry this video is a little long. Hopefully this helps you understand how to do different types of problems when coming to slope-intercept form. And I hope you have a good day. Bye-bye.